Okay, so now in 9.2 we're going to be looking at complex numbers. Okay, so we're still going to be using imaginary numbers, but we're going to combine imaginary and real numbers. All right, imaginary and real numbers. I'm writing good. Okay, so we know what I is, square root of -1. And if we combine the imaginary number I with real numbers, we get what are known as complex numbers. It's a whole other number system, right? It's a combination of real numbers and imaginary. Okay? And it goes in this form here, A plus BI. Okay, you know what the I is, okay? And in this case, in this form, whatever number A and B are, they are real numbers, okay? And I is the imaginary number. Are you with me? Okay, so we have a real part and an imaginary part, and that's what we call a complex number. Right? Let's look at some examples down here. They want us to add and subtract some things here, right? And they've got things grouped in parentheses, right? Now be careful, we're not multiplying here, so we're not really like distributing twice, that kind of thing. So really all we have to do is like, since it's adding, we're just distributing a 1 through everything. You with me? So I can effectively just drop the parentheses here, okay? So this would just equal -2 plus 7i plus 6i plus 2i. All right? So now we're just going to combine like terms, okay? And we want to have it in this form up here, a plus bi, the real plus the imaginary part. So when we combine like terms, let's start with the real numbers. Oh, I have an I on that 6, guys, sorry. Shouldn't be an I there. So let's start with the real numbers. So what are the real numbers in this?
-2 and 6.
-2 and 6. And what's -2 plus 6?
4.
Is 4. And then 7i plus 2i is what?
9i squared.
No. Just 9i. We're not multiplying, we're adding. Right? 4 plus 9i. Simple as that. Okay? Let's do part B. Well, since we're adding, we're distributing a +1, so here we can just drop parentheses, right? So we have 8 plus 4i plus 12 minus i. Let's put it in a plus bi form. What would it be?
It would be 20 plus 3i.
8 plus 12 is 20. Plus, and 4i minus i is just 3i. Simple as that. Okay? Now, part C, we've got to be careful, right? Because we're subtracting the one on the right. So we do now need to distribute that -1 through there, right? Everybody with me? Don't make a mistake of just dropping them here. So we'd end up with 5 plus 3i, and then what when we distribute?
And we should be -2
-2
plus 7i.
plus 7i. Okay? I'm recording, right? Okay. All right, now let's put it in a plus bi form. Take the reals. What do we got?
That we get equals 3 plus 10i.
Plus 10i. Okay, everybody go with that? All right, one more over here. We're subtracting, right? So we got to distribute through, okay? So we get -3 plus 5i, and then what?
And plus 8 minus 2.
Minus 2i. And one more time, a plus bi form. And -3 plus 8, you get what?
5
5. And 5.
plus 3i.
3i. So there are your complex numbers in a plus bi form. Okay? All right, you guys do exercise 2 here. They want to know what the sum of 6 plus 2i and -8 minus 5i is. We take a second and do that one. All right? We're adding them. We don't need to distribute anything but a +1, right? So we'd end up with 6 plus 2i plus -8, so it'd be -8 minus 5i, right? So minus 8 would be -2, and then 2i minus 3i. right? Okay, so that's adding and subtracting. So let's go down to multiplying now and rewriting in the form of a plus bi. We have to remember what I squared equals here. What does I squared equal?
I squared equals -1.
I squared equals -1, right? So let's go ahead and multiply these guys here. So we're going to distribute twice, right? We'll distribute the 3, and then we'll distribute the 5i, okay? So 3 times 7 is 21, right? Plus 6i. And now let's distribute the 5i. What's 5i times 7? Man,
Oh, 20, 35i.
35i. And then 5i times
And
2i.
10i squared.
10, yeah, I squared, right? All right, let's start combining like terms. You see that I squared over there? We'll handle that in a second, right? So the real part of this is what? There's only one real number here. What is it?
21.
So 21 plus, well, 6i plus 35i is, right, these guys, is 41i. And this is 10 times what, actually? 10i.
10 times -1.
Right, okay? So this is 21 plus 41i. Wouldn't it be minus 10? Right?
Yeah.
And now let's combine the 21 minus 10, and what do you get?
Get 11 plus 41i.
Plus 41i, okay? Did I lose anybody with that one? Right? Notice this I squared becomes a -1, and it actually causes you to subtract that 10 instead of adding it. Or if it was originally subtracting, you'd then add, right? Okay? You guys think you can handle one like that? Do part B? All right, for those that didn't, let's run through this. Let's distribute through twice. The what? Why is this doing this to me? Wow. Something's going haywire here. Okay. Jeez. Stand by 1 second. I'm having. All right, so equals -6, right? And then plus 4i plus 18i minus 12i squared. All right, so that gives us -6 plus 20, was it 22i? And that I squared is -1, right? So won't that become plus 12 at the end?
Yes.
I don't think I need to write the, 12 times -1. Hopefully you get that now, right? And so now -6 plus 12 is 6 plus 22i. Okay? Give you another shot there. Take a moment and do part C. Let's make sure we can do these. Okay? Make sure we're not making any arithmetic mistakes. So we end up with, let's see, this equals -20, right? Minus 12i minus 5i, and that would be minus 3i squared, right? Which you know is -3 times -1, okay? So that's -20 minus 17i, right? Plus 3, right? There's no more I on that, right? Because we know the I squared is -1. We just make it, right? So then we have -20 plus 3 would be -17 minus 17i. Okay? Does anybody have any questions on that? You get the multiplying and handling an I squared being -1, okay? I think then we can probably skip that. And there is, and we're going to skip these two examples. We're not going to mess with that business. I'm going to kind of keep it simple here. I do want to give you a quick note, though. something you might see in your homework. See note. Let's go to those pages real quick. I don't think you covered this in algebra. Have you guys dealt with conjugates in algebra?
I think so.
Okay, so conjugates. Probably you did, but you didn't call it conjugates. Okay, so if I have A plus B, the conjugate of that is just A minus B. Okay?
Yeah, I think I remember it.
So if I multiply two conjugates, let's see what happens. Okay? So if I distribute through the A and then distribute through the B, right? Don't I end up with A squared minus AB, right? And now let's distribute the B. Well, that would be plus BA or AB, right? Minus B squared. And then when we combine the like terms, what happens? What do we end up with?
You get A plus.
These guys cancel out, don't they?
I mean A squared.
So we end up with
minus
A squared
B.
minus B squared, right? Okay. And a complex conjugate, well, we know what complex is, A plus BI. Complex conjugates. You could bet with the squaring there, you'd probably end up with an I squared, right? You'd have A plus BI, and the conjugate would be A minus BI, right? Let me give you a quick example. Let's say I have, mother of pearls. Let's say I have 3 plus 2I, and I multiply by its complex conjugate, which would be what, guys?
3 minus 2I.
Right? We'll see what we end up with here. So it would be 9, right? Minus 6I plus 6I, right? Minus what?
Minus 4I squared.
Okay. What happens to those, the negative and positive 6i's?
They cancel out.
Right? So this
I mean,
becomes, that's
And
gone.
I squared would be minus
9.
4, negative 4 squared times
I squared.
1.
Right.
That'd be
So
9 plus 4.
9 plus 4. Hey, look what happens. There's no more imaginary numbers in this, right? And 9 plus 4 is what? 13. Right? So you see we multiplied these complex conjugates and all the imaginary numbers went away. They canceled out in the middle, and you end up with the I squared, which is -1, giving you a real number. Okay? Does that make sense? You probably did you call them conjugates in algebra?
No, I think so. Don't think so.
You
But
just-
we had it that was similar.
Yeah, but you learn how to
Okay,
multiply A plus B times A minus B, but I just gave it a name. And you'll probably see that word in your problem set, okay? Let me give you the problem set that you're gonna work on then. Look how thick that is. So this is really glitching out. We got this down. You're only gonna do numbers 1 through 6. Why? Okay, problem set numbers 1 through 6. All right. Does anyone have any questions on either of these two sections, imaginary numbers or the complex number system? What does I squared equal, guys?
I squared equals -1.
-1, right? Because you're squaring the square root of -1, because that's what I equals. Okay. Let me stop that.